Hello. In this example, we're going to look at finding the derivative using the quotient rule. And the quotient rule is listed here on the screen in order to find the derivative of an expression that's created with a top and a bottom. You can refer to it as a numerator or denominator. What you're going to need to do is know this pattern. And it's the way I say it, bottom times the derivative of the top minus top times the derivative of the bottom, all over the bottom squared. Now, what we want to keep in mind is this is a pattern. So we could define this differently by saying the derivative with respect to x, if we referred to it as a numerator and a denominator, would be denominator times derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator quantity squared. All right, so this is what the quotient rule is. This is what we need to know how to deal with. So let's get started looking at this example. Now, in this example, we have the function y equals 3x plus 1 divided by the quantity x squared minus 4x. So we have a numerator and a denominator, or a top and a bottom. And when I go to differentiate this, the derivative with respect to x of y equals, I'm going to say negative 3x plus 1 divided by x squared minus 4x, you can see we have to take the derivative of the left and the derivative of the right. So this derivative operator applies to both the left and the right-hand side of the equation. Now the derivative with respect to x of y, we write that as the derivative dy dx. If you prefer, you can write y prime, but you do need to make sure that you are writing that derivative notation. So on the left, we have the derivative of y with respect to x. And on the right side of the equation, I'm going to put the bottom, x squared minus 4x, times the derivative with respect to x of the top, negative 3x plus 1. There's always a minus, and then we have the top, which is negative 3x plus 1, times the derivative with respect to x of x squared minus 4x, and that is all over the denominator, x squared minus 4x, quantity squared. So you can see we have two derivatives in the problem that we need to deal with. And you can do that scratch work off on the side, but I do encourage you to always write out your work so that it's nice and organized and I can follow your steps. All right, so this x squared minus 4x, that is going to stay. We don't need to take the derivative of that. And then now when we take the derivative of negative 3x plus 1, I'm going to use the power rule. So the derivative of something linear, negative 3x, goes down to a constant, negative 3, and the derivative of a constant is 0. Keep in mind there's always a minus. Use your parentheses for grouping so you remember to distribute that minus as needed. And then the derivative of x squared minus 4x, we use the power rule on x squared, we get 2x, and then the derivative of 4x is just 4. And that's all over the denominator quantity squared. So if you get to this step on your paper, I know that you understand how to use the quotient rule. But the next step as we work through this is we need to be able to simplify correctly. So first things first, these first two terms I can distribute. That's negative 3x squared plus 12x minus this quantity. And for this second piece here, we need to FOIL. So when I FOIL that, I get negative 6x squared, positive 12x, positive 2x, and minus 4. Again, all of that is still divided over that denominator quantity squared. So now when we go through this and we look at the numerator, we have some terms that we can collect and group. The other thing we want to make sure that we pay attention to is this minus is going to distribute to everything in that second pair of binomials that we FOILed. So make sure you're distributing. Okay, so what do we have here? I've got negative 3x squared minus negative 6x, which is plus 6x squared. So I have 3x squared, and then I have 12x minus 12x minus 2x, that's negative 2x, and then minus negative 4 is plus 4. And then that's still all over that denominator, quantity squared. A little glitchy there. All right, so we have, there is my derivative. Now, when you go to write your answer, you must write the derivative is. When we read math, this equals sign reads as the word is, and then you need your derivative notation on the left. Could be y prime, it could be f prime of x, depending on your independent variable. All of them mean the same thing. But without that derivative notation, you're not going to get full credit on the problem. All right, so last thing, when we do these problems, we do always try to simplify and factor if possible. So first thing I would be looking for in this numerator here is there a GCF? And there's not. And the other thing I might be looking for would be, does it factor? And 3 times 4 is 12. Are there two factors of 12 that will add to give us negative 2? And the answer is no. So this is my final derivative in factored form. And that's just another example of how we can use the quotient rule to find derivatives.